Alright guys, they were dividing rational expressions. Yesterday, we multiplied them, so now they're simplifying and multiplying, and today we're going to divide them. Not that big a deal, really. Alright, you know how to divide fractions already, and this is the property right here that you need to see right here. That is, ever since I've been at Web, somebody's taught y'all really well, and what I hear all the time is when you divide fractions, you keep, change, flip. Keep, change, flip. Well, what that really means is you change division to multiplication, you multiply by the reciprocal of your divisor, and you get this new fraction. Then you see if you can cancel. So here's the number of example numbers right here. Notice they took the reciprocal of the 7/3, changed it to multiplication, got 6/35. Here's one more algebraic example where they did the same thing. Took the second fraction, flipped it as you would say, or did reciprocal, divided, changed division, multiplication, and then got this big fraction at the end. Then you would try to cancel like we did yesterday. Okay, so I'm going to show you three, and that's going to be the video. So let's give it a shot here. First one, still do what we did yesterday. I'm going to go ahead and factor what I can. So factoring first. I'm going to leave it division for a second. On the numerator up here, I can take out an x, which leaves that x minus 6. On my denominator, I've got factors of 30 that have to be negative 11 to be x minus 5 and x minus 6. I can see some canceling in my future. Now I'm going to do reciprocal, change it to multiplication. Take the reciprocal of the second term, put the x minus 5, x minus 6 in my numerator, my x and my x minus 6 in my denominator. Now, two options. You can go ahead and cancel there, or the way your book teaches is they go ahead and make one huge fraction with everything in your numerator and everything in your denominator. So I combine the 2 and the x there if you didn't notice. And then what you do when you get to this step, then you're good to cancel. I need to make that a little smaller, move it up so I can cancel what's left. What I see is x and x are gone, x minus 6 and x minus 6 are gone. So what that leaves me with is a final quotient would be 7 and x minus 5 in my numerator, and a 2 and an x plus 5 in my denominator. Now, x minus 5 and x plus 5 are not opposites, so you can't cancel them and put a -1. Because the x's don't have opposite signs. Remember, the 5's and the x's both have to have opposite signs to be opposites of each other. Try a couple more. This one is just a polynomial times a fraction. Treat it the same way. The first one here, 6x squared plus x minus 15. You may want to come over to the side. That's slide, divide, slide. So I'm gonna slide the 6 over and make that -90. Factor that, which would be x plus 10, x minus 9. And don't forget, that's when we divide now. Divide both of them by 6. Reduce them. That's 5/3. That is 3/2. And then slide again. Slide the 3, slide the 2. I'm going to come back over here and do that. So I'm going to have 3x plus 5 and 2x minus 3 over 4x squared divided by, this one I can actually take out an x, and that would leave a 3x plus 5. And that's really, remember like yesterday, it's really over 1. So what I'm going to do now is I got to change it to multiplication and do reciprocal of the second, or the divisor, or the second term. So make that times. Put the 1 over x over 3x plus 5. Make up one humongous fraction on the numerator. It's just 3x plus 5 and 2x minus 3. In my denominator, it gets a little weird. 4x squared times x is 4x cubed times 3x plus 5. And the only thing I see that's going to cancel is the 3x plus 5s. It's just all I see. So what that's going to leave me with as a final quotient is going to be 2x minus 3 over 4x cubed. And remember, don't be the one who cancels that 2 and the 4 or cancel the x and the x cubed. Can't do it. Don't do it. I know you won't. One more. All right, last one here. I tried to find the hardest one I could find in your book just to show you, just to end up with. So here we go. I'm going to factor the numerator. I need factors of 32 that give me 12. That'd be 8 and 4. So I'm going to x plus 8, x plus 4. In my denominator, factor out the 6. That leaves x plus 7. Over here, I can factor out an x off my numerator, leaves x plus 4. That's convenient because I'm looking at the other ones I've already done. The denominator's difference of squares, which is x plus 7, x minus 7. All right, same steps. I'm going to multiply the reciprocal at my divisor or my second term. So change it to multiplication. Do reciprocal over here, like this. Looking good. Now, I'm going to show you a little bit different way this time. If you don't want to make one big fraction, you are perfectly fine to go ahead right now and go like, well, there's an x plus 7, there's an x plus 7, there's an x plus 4, there's an x plus 4, and it looks like that's all I can do, which it is. So my final answer is going to be x, whatever's left on your numerator, x plus 8 and x minus 7, and whatever's left on your denominator, which is a 6 and an x, and that's it. So that last step, you know, you can make a one humongous fraction if you want, or you can just go ahead and cancel right there. That's up to you, but just be careful. You need to be neat when you do this, because if you're not, you'll lose some stuff and start canceling everywhere and start losing numbers. So be very careful. All right, that's really it. I'll see you tomorrow. We'll work on a few more of these. See you then.